Hello there. Today we're going to talk about ordering integers and non-integers. And this is of course the second video of our signed numbers component. Let's get started. So the first part of today, we're just going to talk about how to order simply integers. And we've already talked about what integers are, so hopefully that knowledge will come in nice and handy. So just to introduce this topic, when we order integers, there are sort of three general things we want to do, right? The first one is to place them in an ascending list. So the ascending list goes from least on the left-hand side to greatest on the right-hand side. The second choice is to place them in a descending list, which means that we put the greatest on the left-hand side and the least on the right-hand side. Now this is backwards to what we're used to, right? Because typically on the number line, the smaller numbers are on the left, the bigger numbers are on the right. So in this case, we're going to do basically the backwards. We're going to flip it, right? And then the third case, we're actually going to talk about this third case first, and I'll tell you why in a second, is we're just going to directly order the two integers using one of the three operator signs. Okay, so what are these three signs? So when we're just ordering two integers, it's easy enough. We simply have to place one of these three signs here. I'm going to go ahead and show you what those are right here. So we have a less than sign, a greater than sign, or an equal to sign. We're going to put one of these three signs between the two numbers we're ordering. So I've done it here for you in an example using 5 and 7. 5 is of course less than 7. We all know that. So we have 5 and then the less than sign and then a 7. A lot of people remember this because technically if you make an L with your finger and you kind of like twist it, that makes a less than sign. That's great. A lot of people use the alligator analogy as well. If you have 5 and 7, the alligator is very hungry, so it eats the bigger number. Whatever floats your boat. Same idea for greater than. The alligator thing still works because now we're saying 7 is greater than 5. So literally that symbol replaces the mathematical phrase is less than or is greater than, depending on what it is you're talking about. And so that's super convenient. And of course, the equal sign, we've all heard of the equal sign. You're simply saying that two things have an equivalency. They're the same. That's pretty self-explanatory. So no need for too much of an explanation there. The one thing I do want to point out is negative numbers, right? So when we're thinking of the number line, the negative numbers that we're dealing with are actually heavily involved in this process here. So let's think about it this way, right? On a number line, we've agreed from our previous section that when we're looking at values that are less, we're generally on the left-hand side. And when we're looking at values that are greater, we're generally on the right-hand side. That's still true. But let's look at what happens with negative numbers. So with positive numbers, let's just take 3 and 1, I guess, because they're both sort of beside each other. We, of course, know that 3 is, of course, bigger than 1. And that is because 3 is on the right side. Right? So the right side is always going to be greater. But look what happens on the other side. If we look on the other side, we actually come up with this phrase. We know that if we're taking negative 3 and negative 1, right, somebody would say, okay, well, negative 3, 3 is a bigger number, 1 is a smaller number, so probably it goes like this, that negative 3 is once again going to be a greater than negative 1. But this is actually completely incorrect. We say actually it's reversed, that negative 1 is bigger than negative 3, or equivalently, negative 3 is less than negative 1. Now, why is this the case? Well, let's look at those two numbers. When we look at negative 3, which is here, and when we look at negative 1, which is here, which one is on the right-hand side? Well, negative 1 is on the right side. Right? So even though it may look a certain way, you actually have to flip everything around when you're dealing with negative numbers. And remember this idea in the future because we're going to talk about where we need to apply this in the subsequent section. Okay? So all you need to do is for negative numbers, you need to reverse. Okay? So anytime you're ordering, you just have to flip whatever it is you're doing. As you can see, the only difference between this sign here, let's use a beautiful highlighter to show you. The only difference between this sign here and this sign here is that they're reversed. Why are they reversed? Because over here, we are dealing with negative numbers, all negative numbers, and over here, we're dealing with all positive numbers, hence the fact that they don't have a sign. So I guess we don't really need this anyway. But just to show you, I made the highlight there. All right? Okie dokie. So our next exercise is to just order straightforward, simple integers, right? And so I would like you to practice this, which is why we have a timer in the corner right here. For exercise 1A, I would like you to put the following integers in order for me, please. I'm just going to write them out quickly for you. They're going to be, let's go with -5, 7, 10, and -2. And now we're gonna do the same order. So I'm gonna ask you for this. I also want you to do the one where it's just all positive. So 5, 7, 10, and -2. So you're gonna have two parts of that question for me to for you to do for me. And then also we're gonna do exercise 1B, which is to order again simple integers. But now I want you to order -5, -7, -10, and -2. Okay, now go ahead and just take a crack at this question, and in 5 minutes, of course, we will take it up together. See you in 5 minutes. Okay, so we are back. I made a couple of changes in the past 5 minutes. First of all, I just changed up the colors. I want to color code this slide so it's a bit easier for you. But second of all, there was a -2 in this location. That's a mistake on my part. It should have been a +2. I did say all the numbers should have been positive, but unfortunately a -2 was actually written there. So do make that change as soon as you can. Okay? Meanwhile, let's go ahead and order these numbers. The first one is pretty obvious here. So we've got -2, -5, 7, and 10. Again, we are doing ascending order, so it's just your simple, basic least to greatest. We do the same thing for the part on the right, except now we're dealing with all positives. So we simply have 2, 5, 7, and 10. Notice the lack of negatives in this case, but other than that, it doesn't really change anything. But I want to show you this red part down here. So now that we're dealing with all negatives, it's sort of tough to conceptualize this really easily. So what I do is I actually assume all positive first, right? And you can do this. It's actually a neat little trick. So if we assume everything's positive in the first place, watch what happens. Well, if we assume they're all positive, that's the same thing happening as here. So I'm just going to copy this quickly. 2, 5, 7, and 10. Right? That would be the case if all these numbers were positive. Right? Now, of course, they're not, but that's really easy because all we got to do is flip everything around. So instead of reading like this, we're going to read like this. So it's going to be 10, 7, 5, and 2. Let's quickly write that in. Right? And now, because all these were negative, we have a negative, 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 and negative, we can just throw back in 4 of our negative signs, just like that. Okay? These two signs look kind of weird, so I'm going to rewrite them. And now, we have this in ascending order. Right? It's now in that form. Right? -10, as we discussed in the previous section, let me just use my black to emphasize this here, this has got to be the least. Because if you think about that number line, -10 would be all the way over here. And then of course, -2, despite being physically the smallest number, 2 is of course smaller than 10, but -2 is bigger than -10, because -2 would be all the way on the right hand side. So, you assume all positive, and then you just have to flip to get the rest of it, okay? Maybe I'll put the flip over here, just so it's a bit more readable than that one. So all you got to do is you simply need to flip the values. Now this only works if over here you had all positives, and then over here you had all negatives. It does not work in the mixed case here. So if you were thinking of doing it for the mixed case, you can't. For the mixed case, you just have to use your logic that you're going to go negative, 0, positive. But if it's tough for you to conceptualize the whole negative thing, and for most people it is because it's just not intuitive to go in that direction, you can go in the opposite direction and then flip everything. And if you just think about the semantics there, you go in the opposite direction, you flip everything, you're just going in the straight right direction. Okay? So that is exactly what you should have had for exercise 1B. And of course, we did the ascending order here. If you're looking for the descending order, you just have to once again flip this again and you'll get the descending order too. Not a problem, right? So the descending order would be -2, -5, -7, and -10. Okay? So everything I said in the previous section, I basically have it here now in the flowchart form. So first things first, you know what? If you have a mix of positives and negatives, or if it's all positives, they just ask you for a straight up ascending order. No need to flip up and flip backwards and do all that good stuff. Your work is done, right? So that is that. However, if they do ask for a descending order, you have to invert the order for positive numbers. This is just intuitive, right? If you're going from least to greatest, you're going least to greatest. Now you're going to go greatest to least. So it's basically like instead of reading this way, you're reading this way, right? That's all you got to do. And of course, if you're going from all positives, which is here in the original highlight, if you're going all positives to all negatives, right, then you can use my little trick that I went over in the previous section and just flip everything. Okay, that's it. So what I've said in words is here in a flowchart form if you're more of a visual learner. So go ahead and review that when you have some time. Okay, now how do we order integers and non-integers together? Well, it's pretty easy. Basically, I want you to use decimals, right? So this slide is called the magic of decimals. Basically, you can write anything you want, integers, non-integers, everything in between, as a decimal. Now, how do we do that? Well, this is pretty easy too. Let's look at first integers. So if we had, for example, 7, how would I write this as a decimal? Very simple, 7.0, right? And if we need more decimals, and we will, you can just go 7.00000, and I have my ellipsis here. You can put as many zeros as you want, it just won't change the value, right? It works with negative numbers too, so if we have -5, for example, this you can also write as -5.0000, and here is my ellipsis. Very easy. Fractions and mixed numbers work the same way. You can just write whatever it ends up being. So for example, if I have, let's say if I had 2/3 here, we know this is equal to 0.6 repeating, and you can write this as 0.666, as many sixes as you need. Okay, if you are working with any kind of a fraction that ends up terminating, so let's go with 2/5, right? We know this is 0.4. You can actually use the same trick we talked about here and just say it's 0.4000, and I have my ellipsis here. You can add as many zeros as you want to the end, and it will go on forever, right? So decimals are basically a very convenient life hack to order whatever it is that you want. For square roots, just evaluate to the appropriate decimal. So if we had the square root of 9, for example, this gives us a very simple value, which is 3. And of course, if you want 3.000, you can do that. If you have an unfriendly square root, like the square root of 8, for example, you would need to plug this into your calculator and then just write it to whatever decimal place that you get, right? Typically, we ask you to do 10 decimal places. And the reason for this is on the next slide, but basically when you're ordering decimals, it's really good to have, as we have here, 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 and here, a lot of decimal places. That is very, very helpful. But basically the point of this slide is that anything and everything can be written as a whole bunch of decimals. Okay? So here is the flow chart of how you list non-integers with integers. First of all, we talked about this on the previous slide. Ensure that all non-integers are converted to decimals. If you don't know how to do this, literally just pump it into your phone calculator or a regular calculator. It will pop out a decimal for you. Okay? The second step here is to write out all non-integers to the 10th decimal place. Okay? This is a good reference number because usually you'll end up needing 10 decimal places anyway. You can also start to incorporate your integers now. If you have an integer, just use this technique here of adding all your terminating zeros that we talked about on the previous slide. Okay, step 3, I'm going to have to switch back to my pen here, but we'll do that quickly, is to order all the non-integers with the integers using terminating zeros. We talked about this on the previous slide whenever you need to. And then the fourth step is to adjust, if we say ascending order, descending order, if you have all positives, all negatives, now you need to account for that. Okay? Now I know that was a whole bunch of talking and a whole bunch of flow charts and information, so I am going to let you try this on your own with actual numbers that I want you to order. Okay? And so we're going to try this. Again, try and use the information from the previous slides. Don't worry, we will take this up if you don't immediately get it. That the goal here is not to stump you, but to really teach this to you. And so I'm going to go ahead and pick some real numbers. Basically, your real numbers are anything. So integers, decimals, negative numbers, positive numbers, whatever the case may be. So we're going to order 7, 7.7. Let's also do 7 and 1/7. We're also going to do, let's say the square root of 48. Let's do also -2, -2 and 1/3. Okay, so I would like you to order these real numbers that I've listed here, and of course we will take this up in a solution way. and I'm going to show you the systematic way in which I would like you to approach this problem. But before all of that, as always, you have 5 minutes to go ahead and try out your math skills to this point. If you need any help, you can go back in this video and go back to the previous slide where I have a flowchart ready for you. Okay? All right. Here's the 5 minutes. Good luck. Okay, so time is up. However, I do have a couple of things to say before taking this up. Number one, I did not specify this, but I did want you to order this from least to greatest. That's just the convention. So whenever someone doesn't say anything, they mean order it from least to greatest. Okay. Also, the second thing is that I did have a hint for you that I forgot to tell you before I started the time. Sorry. That is also a very bad H. So the hint is that in this case, you only need 2 decimal places. Okay? If you would like to use this hint and this information again to reattempt this question, I encourage you to pause the video here and retry this. Give yourself 5 minutes. I will not give you another 5 minutes because that's just a complete waste of your time. But if you would like to do that for yourself, go ahead. This is a great time to pause the video here and reattempt the ordering of these values right here using the 2 hints I've given you below. Meanwhile, I would like to take up the solution here. So, for the purposes of the solution, remember we need the least number up here, right? So we're going to target that, and we're going to try and put the greatest number. Let's just do this in the corner over here. Let's do least here and greatest here. Right? Now, automatically, for the least numbers, we have 2 leading candidates here. We have negative 2 1/3 and negative 2. So obviously, we know negative 2 1/3 is going to be less. But I want to write in the decimal form. So we have negative 2.33, right? And I'm going to use my ellipsis here to indicate that it goes on forever. We don't need that for now, but I want that to at least be there. And I'm going to quickly put a check mark here so we know we've used this. Now, of course, we're going to have negative 2.00. Once again, I'm making use of that ellipsis to indicate that it goes on forever. Then it's kind of like a sort of a grab bag here. What's the second smallest number going to be, right? So 7 is pretty big. 7.7 is also pretty big. 7 and 1/7 is also pretty big. Now, the square root of 48, we don't know the actual value of, but if you do plug it into your calculator, you get a value of 6.928, right? Now, this is going to be our second smallest value because, as you can see, all the other numbers have a 7 that's literally right in the question, right? And of course, if you have 6 point something, it's going to be smaller than 7 point something, right? So, beep, beep, beep. So that's going to be our next value. In this case, we do not put an ellipsis here because we just don't know what the next terms are going to be. We're going to say it's 6.92. That's usually going to be our sort of our rounded figure. Check this off. The next one, again, if this is not intuitive to you, you might want to put the decimals in place and then order that way. But I know it's going to be 7 because we have 7.00. We can use our ellipsis here. Then it's going to be 7.142857. If this looks like it's coming out of nowhere, this is actually from your decimal expansion, right? So that is also a very good thing to keep in mind. Both of those things can now be checked off. And now, for our final term, we have, sorry, we're going to check off these 2 terms. We're going to have 7.7. So we have 7.700, and I can just put my ellipsis right here. So I can just put the greatest right here. Right? And this is really easy to see. First of all, you can see all the negative values are on the top and the positive ones are on the bottom. But also you can do like a little bit of a head-to-head comparison, right? So we start, if we just look at this row here, right? So if we only look at, let's use a highlighter actually. If we only look at what's here, we have this negative 2.3, which we know is less than negative 2.0, which is less than positive 6.9, which is of course less than positive 7.0, which is less than positive 7.1. Remember, we don't really care what's afterwards because it just has to follow that first decimal place at the beginning. And then negative 7.7 is of course bigger than everything, and in this case is the biggest value we are working with, right? And so if anything didn't line up, for example, if I had these 2 inverted, if I had the 2 values here, right, inverted, I would easily be able to see that because I would have 7.0 and then I would have 7.1, right? And of course, we know that 7.1 is going to be bigger than 7.0. I'm just going to rewrite it right there, right? So in that case, you can quickly switch them up. So put them all in decimal form, and then this gives you a very easy head-to-head comparison as to what's bigger, what's smaller, and then you can just order them right away. Okay? And then, of course, the last part is to write this in the actual form it's given. It's basically like a language, right? So if you're given something in, let's say, German, and you convert everything into English, right? You owe it to the person that wrote the question to put it back in German. So let's go ahead and rewrite this using the red ink we had originally. Of course, the smallest number is going to be negative 2.33. That is negative 2 1/3. So that's going to go first. The next value we have is negative 2. That can stay. Then we have the square root of 48. Then we have 7. Then we have 7 and, sorry, 7, the comma looks kind of bad. Then we have 7 and 1/7. Then we have 7.7. Right? And we're just going to check that we have 1, 2, 3, 4, 5, 6 values in the original question, 1, 2, 3, 4, 5, 6 values in our work, and 1, 2, 3, 4, 5, 6 values in the question in the first place. So that means that this order is absolutely correct. Okay? We've double checked it, we've triple checked it, and now we're pretty much good to go. Okay? All right. That is it for today. So I know this was a very dense lesson. We covered a lot of sort of how things work in terms of ordering decimals and how all of that really comes down to play. But I hope it was really helpful, and I hope we really went over it well. And so go ahead and complete the assigned work. The details are on the classroom, and I will see you in the next video. Take care.